fascinating field at the intersection of computer science, artificial intelligence, and linguistics. It focuses on enabling computers to understand, interpret, and generate human language. Whether it's spoken or written, NLP aims to bridge the gap between human communication and machine understanding. From voice assistants to translation apps, NLP is everywhere, making our interactions with technology smoother and more intuitive. In this video, we'll explore the basics of NLP, its core concepts, and real-world applications, guiding you through the journey of how machines learn to process language. Story of NLP dates back to the 1950s, when researchers first began exploring how computers could process human language. Early efforts focused on simple translation tasks, such as converting Russian texts into English. Over the decades, NLP evolved alongside advances in computing power and artificial intelligence. Today, NLP leverages sophisticated algorithms and massive datasets to achieve impressive results. Understanding this history helps us appreciate how far the field has come and sets the stage for the innovations we see today. NLP is built on several key components that work together to process language. These include syntax, which deals with sentence structure, semantics, which focuses on meaning, and pragmatics, which considers context. Each component plays a crucial role in helping computers make sense of language. By breaking down language into these elements, NLP systems can analyze and understand text or speech more effectively, paving the way for accurate communication between humans and machines. Syntax analysis, also known as parsing, is the process of analyzing the grammatical structure of sentences. NLP systems use syntax analysis to identify parts of speech, such as nouns, verbs, and adjectives, and to understand how words relate to each other. This step is essential for interpreting the meaning of sentences and ensuring that machines can process language in a way that mirrors human understanding. Syntax analysis forms the foundation for more advanced NLP tasks. Semantics is all about meaning. In NLP, semantic analysis helps computers understand what words and sentences actually mean beyond just their structure. This involves resolving ambiguities such as words with multiple meanings and interpreting phrases in context. Semantic analysis is crucial for tasks like question answering and information retrieval, where understanding the true intent behind words is key. Pragmatics deals with the context in which language is used. In NLP, understanding pragmatics means recognizing that the same sentence can have different meanings depending on the situation. For example, "Can you pass the salt?" is a request, not just a question. NLP systems must consider context, speaker intent, and cultural nuances to accurately interpret language. This makes NLP a challenging but rewarding field. Tokenization is one of the first steps in NLP. It involves breaking down text into smaller units called tokens, such as words or phrases. This process makes it easier for computers to analyze language, as it simplifies complex sentences into manageable pieces. Tokenization is essential for tasks like text analysis, search, and machine translation, forming the building blocks for more advanced NLP operation. Part-of-speech tagging assigns labels to each word in a sentence, indicating whether it's a noun, verb, adjective, or another part of speech. This step is crucial for understanding sentence structure and meaning. By identifying the roles of words, NLP systems can better interpret language and perform tasks like translation, summarization, and sentiment analysis. Named entity recognition, or NER, is an NLP technique that identifies and classifies key information in text, such as names of people, organizations, locations, and dates. NER helps computers extract valuable data from unstructured text, making it easier to organize and analyze information. This technique is widely used in applications like news aggregation, search engines, and digital assistants. Sentiment analysis is a popular NLP application that determines the emotional tone behind a piece of text. By analyzing words and phrases, NLP systems can identify whether a message is positive, negative, or neutral. This is especially useful for businesses monitoring customer feedback, social media trends, and product reviews. Sentiment analysis helps organizations understand public opinion and make informed decisions. Machine translation uses NLP to automatically convert text from one language to another. Popular tools like Google Translate rely on advanced NLP algorithms to provide accurate translations. This technology breaks down language barriers, making information accessible to people around the world. Machine translation continues to improve, thanks to advances in deep learning and large language models. Speech recognition is another exciting application of NLP. It enables computers to understand and process spoken language, powering voice assistants like Siri and Alexa. NLP algorithms convert audio signals into text, allowing users to interact with devices using their voice. This technology is transforming the way we communicate with machines, making technology more accessible and user-friendly. Text summarization is an NLP technique that automatically generates concise summaries of longer documents. By identifying the most important information, NLP systems can help users quickly grasp the main points of articles, reports, or emails. This is especially valuable in today's fast-paced world, where information overload is common. Text summarization saves time and improves productivity. Text classification involves categorizing text into predefined groups. For example, emails can be sorted into spam or non-spam, and news articles can be classified by topic. NLP systems use machine learning algorithms to analyze text and assign appropriate labels. This process is essential for organizing large volumes of information and improving search and retrieval. Chatbots and virtual assistants are some of the most visible applications of NLP. These systems use natural language understanding to interact with users, answer questions, and perform tasks. From customer service bots to personal assistants, NLP makes it possible for machines to engage in meaningful conversations, providing support and information around the clock. Information retrieval is the process of finding relevant information from large datasets. NLP plays a crucial role in search engines, helping users find the answers they need quickly and accurately. By understanding the meaning behind search queries, NLP systems can deliver more relevant results, improving the overall search experience. Text generation is an advanced NLP capability that allows computers to create human-like text. This technology powers applications like content creation, automated news writing, and creative storytelling. By learning from vast amounts of data, NLP models can generate coherent and contextually appropriate text, opening up new possibilities for automation and creativity. NLP relies on a variety of algorithms to process and analyze language. These include rule-based approaches, statistical models, and more recently, deep learning techniques. Each algorithm has its strengths and weaknesses, and the choice depends on the specific task and available data. Understanding these algorithms is key to building effective NLP systems. Rule-based methods were among the earliest approaches in NLP. These systems rely on predefined rules and patterns to process language. While effective for simple tasks, rule-based methods struggle with the complexity and variability of natural language. Today, they are often combined with more advanced techniques to improve performance. Statistical NLP uses mathematical models to analyze language based on probabilities and patterns in data. By learning from large datasets, these models can make predictions about language use and meaning. Statistical NLP paved the way for more sophisticated techniques, enabling computers to handle complex language tasks with greater accuracy. Deep learning has revolutionized NLP by enabling computers to learn complex patterns in language. Neural networks, especially models like transformers, have achieved remarkable results in tasks like translation, summarization, and question answering. Deep learning allows NLP systems to handle ambiguity, context, and nuance more effectively than ever before. Word embeddings are a key innovation in NLP. They represent words as vectors in a high-dimensional space, capturing semantic relationships between words. This allows NLP systems to understand similarities and differences in meaning, improving performance in tasks like translation and sentiment analysis. Popular embedding models include Word2Vec and GloV. Transformers are a breakthrough in NLP, enabling models to process entire sentences or documents at once. The attention mechanism allows models to focus on relevant parts of the input, improving understanding and performance. Transformers power state-of-the-art NLP systems, including large language models like GPT and BERT. Before NLP systems can analyze text, they must pre-process it. This involves cleaning the data, removing unnecessary characters, and standardizing formats. Preprocessing ensures that the input is consistent and ready for analysis, improving the accuracy and efficiency of NLP models. Stop words are common words like the, is, and that often carry little meaning. Removing stop words during preprocessing helps NLP systems focus on the most important information in the text. This step streamlines analysis and reduces noise, making it easier to extract valuable insights. Stemming and lemmatization are techniques used to reduce words to their base or root forms. For example, running, ran, and runs are all reduced to run. This helps NLP systems treat similar words as the same, improving the consistency and accuracy of analysis. Despite its progress, NLP faces many challenges. Language is complex, ambiguous, and constantly evolving. Sarcasm, idioms, and cultural references can be difficult for machines to understand. Addressing these challenges requires ongoing research and innovation, pushing the boundaries of what NLP can achieve. NLP models can sometimes reflect biases present in the data they are trained on. This can lead to unfair or inaccurate results, especially in sensitive applications. Addressing bias is a critical area of research, as it ensures that NLP systems are fair, ethical, and trustworthy. Multilingual NLP focuses on processing and understanding multiple languages. This is essential for global applications, as it enables systems to serve users from diverse linguistic backgrounds. Advances in multilingual models are making it easier to build inclusive and accessible technologies. NLP is transforming healthcare by enabling the analysis of medical records, research papers, and patient feedback. It helps doctors and researchers extract valuable insights, improve diagnoses, and enhance patient care. NLP-powered tools are making healthcare more efficient and data-driven. In finance, NLP is used to analyze news, reports, and social media to predict market trends and manage risks. Financial institutions rely on NLP to automate document processing, detect fraud, and provide better customer service. The ability to process vast amounts of unstructured data gives organizations a competitive edge. NLP is making education more personalized and effective. Tools like automated grading, language learning apps, and intelligent tutoring systems use NLP to understand student needs and provide tailored feedback. By analyzing student responses, NLP helps educators identify areas for improvement and support learning outcomes. Customer service has been revolutionized by NLP. Automated chatbots and virtual assistants handle inquiries, resolve issues, and provide information instantly. NLP enables businesses to deliver faster, more efficient support, improving customer satisfaction and reducing operational costs. Social media platforms use NLP to analyze posts, comments, and messages. This helps detect trends, monitor sentiment, and filter harmful content. NLP-powered tools enable platforms to create safer and more engaging online communities, responding to user needs in real time. Marketing teams use NLP to analyze customer feedback, reviews, and social media to understand preferences and trends. NLP helps businesses tailor their messaging, optimize campaigns, and deliver personalized experiences, driving engagement and sales. Legal professionals use NLP to review contracts, analyze case law, and automate document management. NLP streamlines legal research, reduces manual work, and helps lawyers find relevant information quickly. This technology is making the legal field more efficient and accessible. Entertainment platforms use NLP to recommend content, generate subtitles, and moderate user comments. By understanding user preferences and language, NLP enhances the viewing experience and keeps platforms safe and enjoyable for everyone. NLP is making technology more accessible for people with disabilities. Speech-to-text, text-to-speech, and language simplification tools help users communicate and access information more easily. These innovations are breaking down barriers and promoting digital inclusion. Security applications of NLP include detecting phishing emails, monitoring for cyber threats, and analyzing suspicious communications. By understanding language patterns, NLP systems can identify potential risks and help protect users and organizations from harm. Researchers use NLP to analyze scientific literature, discover new insights, and automate data extraction. NLP accelerates the pace of discovery by making it easier to process and understand vast amounts of information, supporting innovation across disciplines. Personalization is a key benefit of NLP. By analyzing user preferences and behavior, NLP systems can deliver tailored recommendations, content, and experiences. This makes technology more engaging and relevant to individual users. NLP is driving automation across industries. From automating customer support to processing legal documents, NLP reduces manual work and increases efficiency. As technology advances, more tasks will be automated, freeing up time for higher-value activities. Future of NLP is bright, with ongoing research pushing the boundaries of what's possible. Advances in deep learning, multilingual models, and ethical AI are shaping the next generation of NLP systems. As technology evolves, NLP will become even more integrated into our daily lives, making communication with machines seamless and natural. Ethics is a critical consideration in NLP development. Ensuring privacy, fairness, and transparency is essential for building trust in NLP systems. Researchers and developers must address issues like bias, data security, and responsible use to create ethical and trustworthy technologies. Natural language processing is transforming the way we interact with technology. From chatbots to translation tools, NLP is making communication with machines more natural and intuitive. As research continues and new innovations emerge, NLP will play an even greater role in our lives, shaping the future of human-computer interaction. Thank you for joining us on this journey through the world of NLP.